In this video, we are going to discuss class 11th mathematics chapter 1 sets, and we'll discuss the algebraic approach to the sets. We'll prove certain important laws regarding union of sets and the properties of union and intersection of sets, and also properties of complementary sets. This we discussed in detail in the previous videos. This important formulae, I wanted to refresh them. N A union B is the number of elements of A union B is the number of elements of the individual sets minus intersection elements. If the intersection is have null set, that means if no elements are there, then that becomes the elements are simply added. And you can see the third one is N A minus B. The pink area and N intersection B white area gives you the circle A. Similarly, B minus A, the green area and the white area, N A intersection B gives you the B, circle B, that is set B. And A union B union C, this is given by the formula, and we will give the proof for this also. This These three are disjoint sets, A minus B, B minus A intersection B. The sum is A union B. The complement, properties of the complement sets, A union A dash. This is universal set. It's like axiom because self-explanatory. A union A dash means suppose A is there, a set A union A dash is what leaving out all the A elements, all other elements of the universal set. Put together, if you add them, you will be getting universal set. Second one, A intersection A complement. A complement is leaving out all the elements of A. So there is no common element between A and A complement. That is a null set. De Morgan laws, will see the proof in the next videos. Law of double complementation. This is also self-explanatory. A complement is what? This thing, and complement of this. A complement is outside is this. If you leave out all these elements, you will be left with A. Right? So A complement is A. Law of empty sets and universal sets. Phi complement. That means null set complement. Null set is having no element. Complement means all other elements in the universal set. So that is the universal set itself. And U complement is all the elements complement. You have to leave out all the elements. Then that is left with null set. I'm just revising again the properties of operation union and operation of intersection. Commutative property, A union B is equal to B union A. This is also like an axiom. A union B, and if you join the A to B or B to A, if you, it's like joining. See, like 1 plus 2 is there, or 2 plus 1. The order doesn't make A union B or B union C. Doesn't make any difference, right? It's similar to that. And associative law, I will give the proof in this video only. A union phi is definitely A. And union, universal set, union of A is what? The universal set is there and A is there. If we add A to universal set, what will happen? It is again universal set. Anyway, all the elements of A are present in universal set. The A union A is what? A union, it is adding it to itself. All the elements are there and you are removing the common elements. So A union A is A. Universal union A is what? This is what we have given this. The law of universal set. I think we have repeated this. The distributive law I will explain in this video only. This is with the intersection. All this will be repeated with the intersection. B intersection A. This is also axiom self-explanatory. And this associative law I will give the proof here, and distributive law also give proof here in this video only. Next is A intersection A is what? This is nothing but again A, because the common elements of A are A only. All these things are self-explanatory. In this video, we are going to use this concept a lot. Now to prove A is equal to B, we prove A is a subset of B and B is a subset of A. Then it follows A is equal to B. We'll, I will discuss this in the later part of the video. See, these are the proofs we are going to learn in this video and next videos. So consider two sets A and B. Suppose if you want to prove A equals to B, how do you prove? We'll prove first A is a subset of B and B is a subset of A. Then A equals to this, that implies A is equal to B. This is the approach. So for that, what we'll do? We'll take an arbitrary element x belongs to A, and with some arbitrations, we'll prove that x also belongs to B. Then what will happen? A becomes a subset of B. Similarly, what we'll do? We'll make another arbitrary element that belongs to B. Subsequently, we'll prove that Y also belongs to A. In that case, B becomes a subset of A. It implies that A is equal to B. A is subset of B and B is subset of A. Right? So that is why A equals to B. This is how our approach. This will be the approach throughout our solving the problems algebraically. You remember this. You understand this. Consider two sets will prove each set is subset of the other. That implies that A is equal to B. Next one is C. If X belongs to A union B, that means X belongs to A or X belongs to B. This is very important. For intersections, if X belongs to A intersection B, then X belongs to A and X belongs to B. This is important. This is for union. This is for intersection. If X does not belong to A union B, then X does not belong to A and X does not belong to B. Remember that A union B, X does not belong to A union B. Means what? It is all outside the A union B. So it does not belong to A and does not belong to B. When union it does not belong, it comes and. When it belongs to A, it comes R. Remember that. This is for intersection. This is for union. X. If X does not belong to A intersection B, then it implies X does not belong to A or X does not belong to B. Remember this. When it is intersection, then does not belong to, it becomes R. Last one is, okay, this is A. If X belongs to A, X does not belong to A complement. This is straightforward. This is true. These three things you remember. Okay. This is for union. This is for intersection. Remember this. X belongs to A union B. You will get X belongs to A or X belongs to B. Here, if X belongs to A intersection B, X belongs to A and X belongs to B. If it is not, X does not belong to A union B, it becomes AND. X A and X belongs to B. That AND operator. In this X does not belong to A intersection B. Here you can say X does not belong to A or X does not belong to B. Remember this. I put everything in a single page for your reference. We will see math logical operators. There are 5 operators. We deal only 2, or and. The logical disjunction or is distributive over logical conjunction and vice versa. That means logical disjunction is or and logical conjunction is and. This is or is distributive over and or is distributive over and vice versa. And that means and is distributive over or. See, with mathematical symbols we can write A V. This is or symbol. B caret symbol is and. V is or. This caret symbol is and. Math symbols, these are the math symbols. This V represent or. This caret symbol represent and. So A V B caret C is equal to A V B caret A V C. We'll read this as A or B and C equals to A or B and A or C. Or is distributing over and here inside the brackets. Similarly, A and B or C equals to A and B or A and C. That means this and is distributing over R. R is distributing over and is distributing over R. They will A and B, A and C. This is in our relevance to our sets. We'll write it X belongs to A or X belongs to B and X belongs to C. Suppose this is the statement. In that case, it implies X belongs to A or is distributing over and, right? So this implies X belongs to A or X belongs to B and X belongs to A or X belongs to C. This is the relation. We will use this in our proof of distribution law. Okay. Now we'll see the proof of associative law. That is A union B union of C. That is A union B union C equals to A union B union C. So for that what you have to show is this is subset of this and the second set is subset of first set. See, that means A union B union C is the subset of A union B union C and vice versa. This is the subset of this. Let us take an arbitrary variable x such that x belongs to A union B union C. That implies in union के जगह में we'll write or. A union B means A or, that means x belongs to A or x belongs to B. In place of union you can write or. Union x belongs to C. Now these three things are there. We can regroup them. These three are there. We can take x belongs to A or, and these two together we can keep as a group. That means we can keep these two in a bracket. X belongs to B or X belongs to C. This means what? X belongs to A or X belongs to this B. This definition of B union C. X belongs to B union C. And again X belongs to A or X belongs to A B union C means X belongs to A union B union C. That means X belongs to A union B union C. This is the second set. So first set is subset of second set. So similarly, we'll prove the second set. This one, we prove that this set is subset of the first set. That means this set is subset of this set. We'll follow the same procedure. Let any arbitrary element y belongs to A union B union C, the second set. Then it follows y belongs to A or y belongs to B union C. In place of union, we can write R. So y belongs to A or again B union. In place union, you can write R. In place of union, you can write R. X belongs to B or X belongs to C. Now again the same procedure. Regrouping, we will get y. We are getting y belongs to A or y belongs to B. That means these two we are grouping together, and or y belongs to C. This is what by definition this is y. This is what this is by definition this is A union B, and or A union B or y belongs to C. A union or C means A union within brackets unions C. So after regrouping, we will get y belongs to A or y belongs to B or y belongs to C. This is by definition A union B. So this is y belongs to A union B or y belongs to C. So this implies y belongs to A union B union C. So we started with y belongs to the second set A union B union C, and now we prove that y also belongs to A union B union C, that is the first set. So this second set is subset of first set. So first set, this is the one. A union B union C is the subset of A union B union C. We proved, hence we proved these two sets are equal sets. So this is how we proved the associative law. It is simple, means we have to regroup the elements, and instead of union, we have to, where R is there, we have to put union. That means R union is there, we have to put R. Next, we will see distributive law. Now we will see the proof of distributive law. That is A union B intersection C within brackets equals to A union B intersection A union C. That means this A distributes over the B and C sets inside the bracket. A union B intersection A union C. We'll prove that. To prove this, we have to prove the first set is the subset of second set, and the second set is subset of first set. We'll see first, we'll prove A union B intersection C is a subset of A union B intersection of A union C. Let X, any arbitrary element, belongs to A union B intersection C. Then what? Then X belongs to this, both the sets. X belongs to A or X belongs to B intersection C, right? So X belongs to A or X belongs to B intersection C. We'll further expand X belongs to A or X belongs to B and X belongs to C. This is because intersection is there. We'll write and. Here, this X belongs to A, we can distribute over these two sets inside the bracket. X belongs to A or X belongs to B, and X belongs to A or X belongs to C. This I explained you in detail in this video only, or distribute over and. So X belongs to A can be distributed among these two inside the bracket. That means X belongs to A or X belongs to B, and X belongs to A or X belongs to C. So because R is there, X belongs to A union B. You can write like this, and X belongs to A union C. This is also R. So this A belongs to this A union B, and X belongs to A union C. So and is there, so that becomes an intersection. X belongs to A union B because and is there, intersection A union C. So what is this? This is the second set. So we proved this because if X, when arbitrary element belongs to this first set, that also belongs to the second set. So we can conclude this first set is subset of the second set. This is A union B intersection C is a subset of A union B intersection A union C. Now we have to prove the other way around. This A union B intersection A union C is a subset of A union B intersection C. So we'll see, let Y be an arbitrary element belongs to A union B intersection A union C. Similar, exactly the same way we'll prove this set is a subset of the other one. Now we started with Y belongs to this set and that follows. That means here union is there, intersection is there. So union means we'll write A, Y belongs to A union B and intersection is there. That is why you write I and Y belongs to A union C. You can see Y belongs to A or Y belongs to B. We'll expand this union and Y belongs to A or Y belongs to C. Take Y belongs to A as common and Y belongs to A or Y belongs to B and Y belongs to C. You can do that. Y belongs to A is there in both these things and is there. So Y belongs to A will take out as common or this and this. Y belongs to B and Y belongs to C.
If you observe this, or is distributing over and. We proved that is equal to this in this video only. So what we are doing here is the reverse of it. This equals to this. Okay.
MS. Now this Y belongs to B and Y belongs to C is intersection and this will be or is union. You can replace them and write that means Y belongs to A or Y belongs to B intersection C. And के बदले में we are writing intersection. That means Y belongs to A union because R sign is there. A union. This this is B intersection C. So this becomes Y belongs to A union B intersection C. That means this is the first set. So we started with the second set and ended up with the Y belongs to first set also. Second set is subset of first set. Therefore, A union B is intersection A union C is a subset of A union B intersection C. So we have proved this set is subset of the second set and second set is subset of the first set. So they are equal sets. A union B intersection C is equal to A union B intersection A union C. This is the proof for the distributive law. So to prove the other distributive law, you have to just interchange with intersection with union and interchange and with or. You will get the result.
Hope you understood this algebraic approach for showing the proofs of laws and properties of sets. Understand the concepts thoroughly to be useful for your while solving the problems in miscellaneous exercises and complicated problems. Usually this approach may be required for your questions asked in the final examination. Have a thorough understanding. If you've got any doubts or suggestions, leave out in the comment section. Don't forget to watch the introduction and solutions together. The links to all the previous videos are given in the description box below. Please like and subscribe and share with your classmates and friends to get notifications of all the videos of this channel. Thank you.